In this example problem, we're going to take on the role of a real estate investor in a college town. This real estate investor has a property that they want to rent out, and they're trying to figure out what is the proper predicted rental price for this particular location. And that's actually found down here in C. We're trying to rent out a 1,600 square foot rental that has 3 bedrooms and 2 baths. Well, to do so, we're going to look at some historical information that we have about a bunch of other properties in this college town. As you see over here, for each of the 40 properties we have in our sample set, we have how much it rents for, the number of beds it has, the number of baths it has, and its square footage. The first thing that we need to do is we need to figure out what is the relationship between each of these predictor variables, the beds, baths, and square footage, against the monthly rent that they charge. Is this relationship have one shape or another? And for this particular question, we're looking at just two different things. Is it closer to a linear relationship, so rent increases in a straight line, or a logarithmic relationship, where rent increases for a while and then kind of flattens off? And the best way to figure out which one of these two it is to make a series of scatter plots that will let you see the relationship between the two variables. So we're always going to compare the predictor variable to rent. When you make a scatter plot, you want to have your x-axis, which is going to be our predictor variables, on the left side of your y-axis, which is always going to be our rent. So I'll do it for beds first. I'm going to highlight all of column C, go till I get this little cursor right here, hold down Shift, and move it over so I have them where I want them. Now I have beds on the left and monthly rent on the right. I'm going to grab all the information within those two columns, and once I have that, I'm going to insert a scatter plot. And let's just pretty this up a little bit so I don't get confused about stuff. I'm going to add axis titles. Our y-axis represents the monthly rent that gets charged for the property. X-axis in this case represents the number of beds, and I'm going to have to do this for all 3 of our predictor variables. So I'm going to change the title to something that's easier to notify which is which, and this is going to be beds against rent. Something simple. So what is the relationship between these two? Well, the best way to figure that out is to go to your chart elements, go down to the little arrow on the side of trend line, and go to your more options, and then figure out which one fits closer to a line, whether you have I don't know what's happened to that, where you have a linear shape or a logarithmic shape. Let me bring that up one more time, and trend line, more options. There we go. So to figure that out, I'm going to display the r squared value on the chart, clicking the button on the bottom down here. And for linear, we see that r squared is 0.7406. Well, what is it if we go to logarithmic? It goes down to 0.6617, which means this particular graph right here has more of a linear relationship than it does a logarithmic relationship. So I'm going to denote in my information that beds seems to have a linear or LIN relationship. And I'm going to close this out. Let me shrink down my chart a little bit so I can just hide it off to the side. I got to do the same thing for the other 2 variables. The next one we have on our list is baths. So again, I want monthly rent as my y-axis on the right side of baths. So I'm going to bring that over one more time. There we go. Highlight the 2 variables that I have, number of baths and the monthly rent. Grab all the information, and one more time, I'm going to insert a scatter plot. And just like I did before, so I don't get confused, let me add some titles. The y-axis, as always in this problem, is going to be our monthly rent. Down here, the x-axis in this case is the number of baths. And I'll change the title to baths against rent. So now, just like before, I want to establish what fits better, a linear or a logarithmic relationship. So I am going to go through and add in a trend line using the More Options tab. And let's look by putting our r squared on in the corner. A linear relationship has 0.5291, while a logarithmic relationship drops down to 0.4931. So a linear relationship better fits the relationship between the number of baths a house has and how much it charges for rent. So I'm going to put that into my information for baths. That guy's going to be linear. Close out my little pop-up box, shrink this guy down and hide him off to the corner again. And let's do this for our third predictor variable, which this time is square footage. So I'm going to go move my monthly rent over so it's on the right side of square footage, so I can just insert a scatter plot by highlighting all the information now in these two variables with square footage on the left and monthly rent on the right. Insert a scatter plot. Pretty up my graph just a little bit by adding axis titles. Y is going to be monthly rent, and the x-axis in this case is the square footage in terms of square feet. Call this graph SQFT for square footage against rent. Now let's go through and figure out which relationship fits better. Is this a linear relationship or a logarithmic relationship? So I'm going to go to chart elements, I'm going to go down to the trend line to more options, and I'm going to put my r squared on by clicking the bottom checkbox. For a linear relationship, our r squared is 0.7043, and for a logarithmic relationship, it jumps up to 0.8268. So it appears to be that rent increases at a greater rate when you go from a very small house to a medium-sized house, but then going from a medium-sized house to a very, very big house, your rent tends to level off. There's not a linear relationship here. This relationship is logarithmic. So I've established the relationship between rent and each of my three predictor variables. Don't want to do that. Undo. So much stuff going on right now. There we go. Now I need to establish my regression equation. Well, I need to do a regression analysis. Linear is the relationship for beds and baths. So we can leave those charts, those columns, as is, because by default Excel works with a linear relationship. But if I want a logarithmic relationship like I do for square feet, I need to change my variables into the log of those particular variables. And what I can do here is in the ln of square feet column that I've already inserted for us, I can just find the log by using the ln function of our square foot. So the ln of cell D2 will give me the natural log of 500, which is 6.214, etc. And now I can just fill handle that in the whole way down the column, and I have the natural log of every single one of my listed square footages. And I want these to be my three variables that I'm going to use to make a regression equation. I want to have the number of beds and the number of baths as is because they're linear, but then the log or the ln of square feet because that is a logarithmic relationship. So let me move this over into a spot where I can highlight all three at one time. Perfect. There we go. And now I can go to my data analysis toolpack, use regression and open it up. And for my ranges, I got to delete out all my old ranges because it's Excel and that's the way that it works. I'm going to highlight as my Y range the thing I'm predicting for, which is monthly rent. So I'm going to grab the entirety of column F cells F1 to F41. And for my X range, I'm going to use my three predictor variables, beds, baths, and the natural log of square feet, grabbing everything within that column. I included the first row, so I want to make sure I have labels on, and then I can make my output range wherever I want to have my information for easy access. Let's just put it right down here in cell H24. And then I hit OK, and I get the following return right here. And what this is saying right now is that the number of beds and the number of baths we have increase the predicted rent by that amount, and then the square footage that we have increases rent by about 675, but it is logarithmic, so it's going to be recorded at a curve. And I can input these returns that I got, my coefficients, into the regression equation for this model. We want to have it as the intercept equals negative 3,909 and some, etc., plus the coefficient for our number of beds predictor variable, which since it was linear, I'm just going to put in as is, 131.78 if you round off. Number of baths is our next variable, also has a linear relationship. I'm just going to bring it in. And I'm going to use the same coefficient that we have down here for the square footage, but I need to know, since it's a logarithmic relationship, that I need to not just multiply it by the x value that we're predicting for, but the natural log of the x value that we're predicting for. In this case, the natural log of 1,600 square feet. So with that, I can go and I can throw in my equation. I can determine what my predicted rent is going to be for, scroll up a little bit here, in C, a 1,600 square foot rental that has 3 beds and 2 baths. Well, it's going to be equal to our constant, our intercept, if you will, plus the coefficient for our first variable, and our first variable is the number of beds that we have. So I'm going to take the 131.781 and multiply by the number of beds in the place that we're testing for, which is 3 beds. Close that. Plus, in the second set of parentheses, our coefficient for the number of baths, which is that 36.4255, times the number of baths this particular property has, which is 2. And then I'm going to multiply that by the coefficient for square footage, which is 675.2648. But since that had a logarithmic relationship, I'm not just going to multiply it by the 1,600 square feet of this property. I'm going to multiply it by times the natural log, so ln, to bring in the natural log function. Open a parenthesis, type in, I should say, the square footage that you're testing for, which is 1,600, and then close both parentheses. So all in all, your formula should look a little something like that right there. And when I put all of that information in, I'm going to get a return that is $1,540.38. That is what the predicted rent is that we're going to be able to charge for this property. How good is our prediction going to be in comparison to what other properties on the market, these other 40 are? We can determine that by the adjusted R-square. We have more than one predictor variable, so we're going to use the adjusted R-square. And our adjusted R-square is 0.8355 when rounded off. So all in all, in this case, we're feeling real confident about our model. 0.8355 is an incredibly high adjusted R-squared for a model that has 3 predictor variables. We believe that this model right here is going to do a very accurate job of predicting our rent. So we're going to charge somewhere in the vicinity of $1,540. We might be a little overzealous at first and put it on for like $1,600 and see if we have any takers before we drop down to $1,550. But because we realized that the relationship between beds and baths was linear, but we used a logarithmic relationship for our square footage, we got a number that has an incredibly high adjusted R-squared and should help us accurately determine what we should be charging for rent on this particular property.